Hi, in this video I'm going to go over the solution to the LeetCode problem 222, count complete tree nodes. We are given the root of a complete binary tree, and we need to return the number of nodes in the tree. According to Wikipedia, every level, except possibly the last, is completely filled in a complete binary tree, and all nodes in the last level are as far left as possible, and the tree can have between 1 and 2 to the h nodes inclusive at the last level h. We also need to design an algorithm that runs in less than O of n time complexity. So the first thing we can do is in the method count nodes is if there are no nodes in the tree, then we return 0. So if root is none, we return 0. And then we can note that we can create an optimal solution if we know the height of the left and the right subtree of the root. Because if the height of the left subtree is equal to the height of the right subtree, then we will have a complete binary tree. So we first need to write a method to find the height of a tree, of the left subtree. So we can say def left height, then pass in self and root. In this method, we first initialize a variable height to be 0, and then we can use a pointer, tree node pointer called traverse pointer, and set it equal to root. And then we can have a while loop that continues iterating until traverse pointer is not none. And all we need to do is say traverse pointer is equal to traverse pointer dot left. And then in each iteration we just increment the variable height. And then upon completion, height will have the height of the left height of the root. So we can say return height. So we'll call the variable up here left height to hold the height of the left subtree of the root. And then say self dot left height, then pass in root dot left. And we also need to do the same thing for the right subtree of the root. So we can just copy this method, paste it below, and then call it right height, and then just change this to be, in each iteration, traverse pointer should point to its right subtree, the root of its right subtree. And then up here we can just say, copy this and say right height equals self dot right height root dot right. Okay, and like I said previously, if left height is equal to right height, then we have a complete binary tree. And the number of nodes in a complete binary tree is 2 to the h minus 1, where h is the nodes on the path from the root to a leaf. However, our notion of height is the number of edges on the path from a root to a leaf. So we need to then return, we can use the power function to go 2 to the h, 2 to the height, which we can use left height or right height. So I'll just say left height plus 1, and then subtract 1. Since I mentioned previously, our notion of height was the number of edges. However, in the formula for the number of nodes in a complete binary tree, they consider the number of nodes on a path from the root to the leaf. Now, if left height is not equal to right height, that means we have a nearly complete binary tree, not a complete binary tree. So some nodes on the last level are missing, making it not a perfectly complete binary tree. So in this case, we know that we have a root node, so we can initialize a variable nodes to track the number of nodes in the tree to be 1. And then we need to find the number of nodes in the right subtree and add them to nodes. So we can say nodes equals nodes plus, and we can make a recursive call to count nodes. Count nodes root.right. And then we need to do the same for the left subtree. So we can copy this, just change it to be the left subtree. So then nodes will equal nodes plus count nodes root.left instead. And then after this, nodes will have the number of nodes in the tree because it counts the root node, and then the number of nodes in the right subtree, and the number of nodes in the left subtree. So then we just need to return nodes. So we can run this now. Oh, yeah, need to put self there. Let's try running it. Okay, let's submit it. Okay, so the solution does pretty well in runtime and okay in memory. Thank you for watching.